We're going to start by looking at surds, i.e. numbers expressed or including square roots. So let's look at this example first. We're going to have a look at the square root of 75. We'll be often asked to simplify surds. In this case, that means making the number in the square root smaller. I'll show you how to do that. Look at the number 75 and look at its factor pairs. In this case, 1 times 75 is 75, 3 times 25 is 75, and 5 times 15 is 75. What we're looking for is a square number. Here the square number is 25. So it's this middle factor pair that we're going to use, i.e. we're going to break down the 75 into 3 times 25. I'm going to break the square root into 2. It's going to become square root of 3 times the square root of 25, and these things are all equal. Now the reason we're doing this is because if you look at these two square roots now, you can see square root of 3, that's an awkward number, but the square root of 25, that becomes just 5. That's why we looked for a square number a minute ago. So what was a very large square root, a very large surd, now becomes, we'll put it the other way around, 5 times the square root of 3, and we can write it just like that. Alternatively, we might be given two surds, like the square root of 6 and the square root of 8, and asked to multiply them together. Now, if you apply what we did here in reverse, you can see that we can put those two together as one square root, i.e. 6 times 8 is 48. So that becomes one surd. Now, that might not be the final answer, because in the same way as we did up here, we might be able to simplify this. Again, we look at 48 and we look at its factor pairs. 1 and 48. There's no square number. 2 and 24. There's no square number. 4 and 12. Well, 4 is a square number, so we might be able to use this factor pair. And then there's just 6 and 8. In this case, there's only one set which has a square number in it, so we'll have to use that. So 48 can become the square root of 4 times 12. Again, we can break that into 2. Square root of 4 times the square root of 12, i.e. the square root of 4 becomes 2 and the square root of 12. So this has simplified to that. The next stage, we might be given something a little bit more complex. We might be asked to take two surds which involve a combination of normal numbers and surds, and we might be asked to multiply those together. Now we do this just by looking at the ordinary numbers first and then the surds second. So 5 times 3, that gives us 15. And secondly, 5 times 2 inside square root gives us 10. So 15 square root of 10. Again, this might not be the final answer. We need to look at the square root of 10. We need to look at its factor pairs. 1 times 10 is 10, 2 times 5 is 10. In this case it only has 4 factors, it only has 2 factor pairs, and none of these are square numbers. So in fact, this is the final answer, this is the simplest form. The final thing we're going to have a look at with surds is division. Now division is very similar to multiplication, so let's have a look at this example. We're going to have the square root of 24 divided by the square root of 2. We've currently got 2 square roots. We can actually write this as just 1 square root, which takes in the same 2 numbers. This calculation here, 24 divided by 2, is just done in the normal way, so it becomes square root of 12. In the same way we've done all the way through, we then need to just check that the square root of 12 can't be simplified in any way, so we look at its factor pairs. So 1 times 12 is 12, 2 times 6, and 3 times 4. They're all the factor pairs. We're looking for a square number. 4 is the square number. The others don't include square numbers, so we break it down in that way. So square root of 12 becomes the square root of 3 times the square root of 4. This becomes 2, so square root of 3 times 2, and rewritten with a number first and the surd second, 2 times the square root of 3.